Alright, in the last video we have seen how to traverse a double linked list. Now here we will look at how to reverse traverse. We know that in double linked list there's a backward connection between nodes, so this means that we can traverse backwards through the nodes over here. So what we are going to do over here is that we are going to start traverse from the last node and we are going to continue until we reach the node 1 over here, first node. Now in our case we are going to start from node 4 and then we are going to go to node 3, then node 2, then node 1. Now here the logic will be like this. First we are printing out the value of the last node, so in this case last node's value will be 4. Then we are continuing to the node 3 and printing out its value to the console, so node 3's value is 3, so we are printing out to the console 3. Then we are continuing to the second node and printing out its value to the console, so in this case node 2's value is 2, so we are printing out 2 to the console. Then we are continuing to the next node, which is node 1, so we are printing out the node 1's value to the console. So when we reach the first node, we are stopping over here. This means that we have finished backward traversal of double linked list. So here it's called reverse traversal. Now the algorithm of reverse traversal is like this. So here also the first thing that we are going to do, we are going to check head value. So if head equals to null, so this means that the double linked list does not exist, so we are going to terminate our algorithm. If it is not equal to null, in this case we are going to start loop from tail to head and printing out their values to the console. So as we shown over here, we are starting from the last node, which is node 4, then we are going to node 3, then we are going to node 2, and then we are going to node 1. And in each step we are printing out the value of current node to the console. Now this is how the logic of the reverse traversal look like. Now based on this algorithm, let's see how it is working in practice. Now here again, inside this double linked list class that we created before, we are going to create a new method after the traversal method that we created in our previous lecture. So here in this case, we are going to create for reverse traversal. Now I'm going to declare our method like this. So public void reverse traverse DDL. Now here again, our method will not take any parameter because in this case we are going to traverse from the last node until the first node, so this means that a parameter is not required over here. Now as we mentioned before, the first thing that we are going to do, we are going to check head value. So if head is not equal to null, this means that our double linked list exists, so we can continue to the traversal. So in this case here also, the first thing that I'm going to do, I'm going to create temporary node which will take the current node's value. Now in this case, as we mentioned before, we are going to start from the last node, so that's why I'm going to set the value of this temporary node to tail, because in tail we know that it references to the last node. So as we are going to start from the last node, we have to set the tail to this current node over here. Now then we are going to start loop through the double linked list. So here again we are going to use the size property of double linked list, because in size we have the number of nodes that we have in our double linked list. So the loop will be like this. For I int equals 0, then size will be I will be the less than size and I will be increased by 1. Then here we are going to print out to the console the value of temp node. Then for making our code more readable, I'm going to put here also an arrow between the printed values to the console. So here again we are going to write if condition like this. If I is not equal to size minus 1, because in this case we have not reached the last node, in this case I'm going to print out to the console the backward arrow. So in this case, as we mentioned that in reverse traversal we are visiting from the last node to the first node, so that's why the arrow is going to be like this. So with this we are making our code more readable. Now then after this if condition, I'm going to set the temporary node to the temper.previous reference, because in this case as we start from the last node we have to go to the first node, so to go to the first node we have to use previous reference. Now as you remember, in case of traversal we were using next reference, but here we are going to use previous reference. So with this we have almost completed our method, so we just need to write the else condition over here, because if the head is equal to null, in this case double linked list does not exist. So I'm going to just copy the message from here in which we have mentioned it and paste it inside this else condition. Then at the end, as we mentioned before, to make our code more readable, I'm going to print out to the console new line character. So with this, we have completed our method. So what we have done over here is we start from the last node and we continue to visit the all nodes of the double linked list from last node to first node and printing out their values to the console. Now let's see how this is working in practice. Now here inside main class, as we mentioned before, we have created double linked list and we have inserted nodes over here. Then we are traversing through this double linked list in a forward way. Now then I'm going to put reverse traversal method over here to see how this is working. So if you put this traverse DDL and reverse traverse DDL side by side, we can see the difference very clearly. So if I run our code, now you see that in the first line of output, we are traversing double linked list. So here we are starting from the first node, then we go to the second node, then third node, and then the last node. Now in case of reverse traversal, we are starting from the last node. As you see, the last node is 4, so we are starting from the last node. Then the node before the last node is 1, then 3, then 2. So in this case, we are traversing in reverse order. So as you see, everything works the way that we want. Now let's see what's the time and space complexity for reverse traversal. So here again, we are going to start from the first line of this method. So in the first line, we have if condition in which we are checking head value. So this if condition is of one time complexity. Then in the next line of code, we have created temp node and we have assigned tail to this temp node over here. And it's obvious that this is also of one time complexity. Then we have a loop condition, so in which we are visiting all nodes of the double linked list. So if the size of the double linked list is n, so the time complexity for this loop will be O(n). Now inside this loop, we are printing out the value of temp node to the console, so this will take a one-time complexity. Then inside this loop, we have another if condition in which we are checking that if I is not equal to signs -1, we are printing out to the console this arrow, so this one also will take a one-time complexity. Then we are setting temp node to temp previous, so this one also will take a one-time complexity because this is just simple assignment statement over here. Now in the else condition, we are printing out to the console that the DL does not exist, so this one also will take a one-time complexity. Now at the end, we are printing out to the console new line character, so this one also will take a one-time complexity because this is not time-consuming operation. Now if we combine all these complexities over here, we get O(n) time complexity because n is dominant term over here. Now the space complexity is O(1) because in this case an extra memory is not required to perform these operations over here. So that's why space complexity is O(1). Now with this we have come to the end of this lecture. So in this lecture we have discussed reverse traversal in double linked list. So basically reverse traversal means that we are starting from the last node and continuing until the first node and printing out each node's value to the console. So hopefully everything is clear about reverse traversal that we discussed in our lecture. So see you in the next lecture.